Hello, I'm Joel Schultes at Colorado Mesa University, and I'm going to give you just a very brief update on where we've done for data analysis related to hydrology at Badger Creek at the two restoration sites that we're working on. We've got two sites that we've instrumented, what I call the control reach and the treatment reach. The control reach is within the historic IM on state land board land, and then the treatment reach is on BLM land, call it BLM 53. So just downstream of County Road 53. The treatment reach was treated back in, I believe, 2021 in June. And then the control reach was actually received some sod speed bump treatments this past year as well, but it had been our kind of untreated reach for a couple of years. We've got two transects of groundwater wells, these pink dots. At each site, we have surface water loggers. We're just measuring stage, we're able to develop rating curves. And then at one of the transects, we also have the surface water level, those blue triangles. And finally, we have a meteorological station down on the treatment reach. In April, we got to see some really good flows as the ice was melting off within the valley. I believe this was simply just like the ice that had accumulated from snow down in the valley bottom melting. And so this came up pretty quickly over the course of the day as the day warmed up and created quite a good flow, as you can see, spread out and unchannelized in the treatment reach. In October, when we retrieved our loggers and took some additional measurements, we also had some good flow. It had been a decently wet late summer, or at least there had been some recent rainfall when I was out there that October. Overall, there's about 10 inches of precipitation at our precipitation gauge. Fairly well spread out. Of course, it looks like July was pretty dry. So one of the kind of new analyses I finally got to put together based on a cross-sectional survey at our well transects is putting together the elevation of the ground with the elevation of the groundwater. Kind of very basic thing, but good to look at and visualize because it tells us what are these streams, how is the stream flow, the elevation of the stream flow related to the groundwater elevation. And so on the control reach, we've got blue and green lines. So here's the surface water in the stream, and then we've got the groundwater across the well transects. It looks like they connect through the stream, but I just didn't plot it, super thoroughly. So you can see the surface water elevation as these short lines, and then the groundwater elevation as these longer lines. In April, at the upstream control transect, they're about the same. Downstream, you can see that in April it's a little bit higher, and but nevertheless, both of these show that the groundwater is intersecting with the channel itself, meaning the groundwater will be contributing to flow in the channel. And this is not surprising. It's a little bit more of an incised channel than down in the treatment reach. So it's intersecting the groundwater table. However, the groundwater table is higher here. It's higher relative to the channel. And our observations have shown us that the upstream reach has been more perennial. And this is likely why, because the groundwater table happens to be higher for whatever geologic or topographic reason. Looking downstream at the treatment reach, in October, the groundwater table is the highest it's been in a very long time. And the stream had flow. I rarely see flow there late in the season. And that plays out with the groundwater table observations, meaning the groundwater table was just intersecting the channel itself. And so we had some base flow contribution there. In April, you can see that it's much lower, about nearly, not quite, but half a meter below the channel. So in general, the treatment reach is a losing stream, meaning whatever surface flow comes in is going to be contributing down to the groundwater table. And that, again, is just a geologic and topographic phenomenon. Whatever restoration treatments have occurred can potentially help retain and store more water in the water table, but it's going to come out somewhere downstream. It's not going to be contributing necessarily to the reach that we're looking at. So here is the summary of the groundwater levels at both sites. Control is on the right, treatment is on the left. The blue and green lines represent the water table. Well, 1 through 4 is essentially, if you're looking downstream, 1 is going to be on the right side, and then 4 is going to be on the left side. And so the 2 and 3 are going to be straddling the channel on either side. What I'll be doing to kind of wrap this up is to look at the slope of the water table towards the stream, and then also how long we are recharging, gaining versus losing. So that's just an analysis I haven't run yet on this. But what we see overall in terms of the pattern is that the control reach is simply a little more perennial. I've got this dashed line representing the Thalweg elevation, or the channel bottom elevation. And you can see that the groundwater is typically above that elevation for both sites, especially for the control 2 site. Going over to the treatment, you can see that the groundwater table falls below the channel elevation, especially in the summer season. So that's indicating that losing condition, where if the water table is below, then any surface water is going to fall below and contribute down to the water table. But it does come up, it does respond to rainfall events. And so that's what we see here with these peaks that correspond to rainfall events. But we do see the treatment channel drying up simply because of that losing condition. Briefly, I got to do some more evapotranspiration analysis. And I presented on this last time, the OpenET. This is a web-based application that uses really coarse resolution satellite data, about 10 meter pixel resolution. But it allows us to look at, over many years, as it goes back to 2018, the patterns of evapotranspiration. And so essentially you can draw polygons around the treatment reach, which I believe is somewhere around here, and then the control reach somewhere up here, and see how evapotranspiration at this core scale varies. So I've got patterns of evapotranspiration, and then the greenness, this green line represents kind of the greenness of the vegetation on a monthly basis. But kind of more importantly is just how much do we see a change in evapotranspiration at this scale between the treatment and control sites. And what this is showing is just total evapotranspiration in feet on the left axis, and then the change between the two. So treatment ET minus treatment control. And we don't see a strong pattern here. We don't see a big change between the two sites. And the question here was, does the treatment show a change in evaporation, a measurable change in evapotranspiration or not? And right now the answer is we don't really see a big difference. If all these blue points were on one side of the line, that would indicate, on the upper side, that would indicate that the treatment reaches evapotranspiring more. Another way to look at this is with some higher resolution data. So Planet Labs is a constellation of satellites that give you 3 by 3 meter pixel data. And this is showing the greenness. The red represents greenness with near infrared. What we're doing is pairing these kind of relatively high frequency, so about every week, satellite imagery with on-the-ground weather station data. So the weather station data right there gives us all the variables that we need: the solar radiation, the winds, the temperature, humidity, etc., that allow us to calculate reference evapotranspiration, like some reference crop, and then we can convert that to actual based on the greenness and type of vegetation that's growing in this area. So I'm still working on this, but we've got now a time series of greenness at this high resolution that tells us basically on a weekly, well, it's actually a daily basis. I'm just showing kind of weeks here, how green the sites are based on the satellite imagery. So at a 3 meter pixel basis. And here's the trend for 2022 that just shows you, here's the control and treatment, how these vary. And what we're going to be interested in looking at, that right now this is just greenness, but eventually we'll get evapotranspiration for the two sites, is how much they're evapotranspiring at this kind of higher resolution scale based on the ground data. But one really quickly, what we do see here is that the control looks like it's staying greener for a little bit longer. And I think that ultimately gets down to the groundwater contributions, the kind of near water table, near surface water table that we see at the control reach. And here's just an image of the two reaches in July of 2022. So we've calculated reference ET for 22 and 23 based on the weather station data. What we'll be doing then, this is a daily time step, is connecting that with, essentially it's called a crop coefficient, but it'll allow us to say, okay, for each pixel, relative based on greenness, how much actual evapotranspiration do we estimate to be occurring based on this single reference ET measurement. So we're taking this for each day reference ET measurement and then attributing it to each of these pixels and converting that to actual evapotranspiration. So we'll get another graph that gives us kind of a more accurate representation of evapotranspiration based on the daily site conditions. So what the road ahead, we're going to be wrapping this study up, at least the initial phase of it, this spring, and going to continue working on those high resolution evapotranspiration measurements. There's some more surface and groundwater data analysis we need to do related to how often we're filling or draining the water table based on those runoff events across the two reaches. And we expect to get that report sometime in May or June of 2024. And then we'll also hopefully continue to do this monitoring. There's a couple things in the air, but it sounds like we'll be able to continue the hydrologic monitoring and get some, continue this long-term data analysis over the coming years. So stay tuned on that, and thank you.